everyone, welcome back to my channel. So for today's video, we are going to talk about geometric sequence and geometric series. So please watch until the end of the video so that you can learn and you can get something out from that. So for today's video, we are going to talk about geometric sequence. So for the past session, you already know what is an arithmetic sequence. As of today, I am going to explain and to show you what is geometric sequence all about. By definition, a geometric sequence is one where to get from one term to the next by multiplying the same number each time. This number is called the common ratio or denoted by R. So previously, sa arithmetic sequence, we can obtain the next term by adding a constant number, and that number is called the common difference. But for geometric sequence, we can obtain the next term by multiplying a constant number, and that number is known to be the common ratio. So basically, that is the difference of the two sequences. For example, 2, 10, 50, 250, and so on. So how are we going to know what type of sequence is this? So as we notice, the second term 10 is obtained by multiplying 5 by 2. And the next term, which is 50, is obtained by multiplying 5 by the second term 10. And for the next term, 250 is obtained by multiplying again 5 to the third term, and so on. So what we have noticed here is to get the common ratio, i-divide natin yung second term sa first term, third term to second term, or fourth term to third term, and so on. So that is the process on how you are going to get the common ratio of the sequence. So therefore, we can say that the common ratio is 5. Another example, 90, negative 30, 10, negative 3 and 1/3, and so on. So how did we get the common ratio? Simply, I will divide negative 30 divided by 90. So second term divided by the first term. The third term divided by the second term, and so on. So you get negative 1/3 as the constant or the common ratio of the sequence. So do the same process. 10 divided by negative 30 is negative 1/3. And of course, negative 3 and 1/3 divided by 10 is negative 1/3, and so on. So I can say that the common ratio is negative 1/3. Again, how to get the common ratio of the given geometric sequence? Just divide the second term to the first, the third to the second, and so on. Are we clear? Okay. Are we clear? Very good. So therefore, the common ratio can be obtained by dividing the second term to the first. So that is a sub 2 over a sub 1, or symbolized by alpha 2 over alpha 1. How do we find the nth term? So for example, what is the 20th term of the given geometric sequence? So masyadong mataas. If we keep on multiplying constant number, it will take time for us to obtain the nth term. So therefore, it's very important to derive a formula so that we can get the nth term in the geometric sequence. So Again, always remember that the R here is the number you multiply to get to the next term, or known to be the common ratio. That is the symbol of R. Okay? So, dapat maiintindihan natin yung mga symbol so that it is easy for us to know or to find what is being unknown. And A is the first term of the sequence. So that is A sub 1. Magkapareho lang sa arithmetic. Okay? A sub 1 is the first term of the sequence. For example, in the given sequence, 2, 10, 50, 250, and so on. How to get the nth term? Or shall I say, the 20th term, the 30th term, and so on. So simply, we are going to identify first the given. So we have here the common ratio, which is 5, and your A sub 2 or A sub 1 is 2, or the first term. So after that, as you notice, this is the pattern. To get my second term, I multiply the first term by the common ratio R. Is that true? Yes. And to get my third term, I multiply the second term by R again. So that is A R times R. So that will become A R squared. And to get my fourth term, I multiply the third term by R again. So that is AR squared times R. So that will become AR to the power of 3. As what you have noticed, to get the third term, you have there the exponent of 2, and that is n minus 1. And to get the fourth term, you have there r to the power of 3, and that is n minus 1. So therefore, to get the nth term, you have to have a sub 1 times r to the power of n minus 1. So that is the constant formula. Okay? So this is the same to all geometric sequences. That to get the nth term, you are going to use a sub n is equal to a sub 1 r to the power of n minus 1. How are we going to find the nth term of the geometric sequence? So for example, this is the question. Find the sixth term of the given sequence, 3, 9, 27, and so on. So it is very important, grade 10, that we are going to find the given. So our first term is 3, and the common ratio is 3, and we are going to find the sixth term, or a sub 6. Remember that to get the common ratio, you have to divide the second term to the first, the third to the second, and so on. So that will become 9 divided by 3 is 3. And so 27 divided by 9 is also 3. So we can say that the common ratio is 3. Right afterwards, we are going to use again the formula in finding the nth term. So you have there a sub n is equal to a sub 1 r to the power of n minus 1. And simply substitute, our first term is 3. And our second term, and our common ratio is also 3 as our r to the power of 6 minus 1. Yn is equal to 6 because we are finding the sixth term or the nth term. So that is the 6 minus 1. So simplify first with exponents. So that is become 3 times 3 to the power of 5, as 6 minus 1 is equal to 5. So right after that, copy again 3, simplify numbers with exponent first. 3 to the power of 5 is 243, times 3 is 729. So therefore, the sixth term in the given sequence, 3, 9, 27, is 729.